All right, concentration of solutions. What does that mean? So when we look at a solution, and we're talking pretty much an aqueous solution. So for example, one like this, where you have some sodium chloride dissolved. I don't have the water molecules positioned correctly around those particles, but they're dissolved in the water. We're going to say this is a lower concentration. To make it higher, we add more salt particles, right? Dissolved salt particles. We could change this concentration also if we removed some water molecules and they became less water molecules to salt particles ratio. But that's what it means when we talk about concentration. Talking about how many solute particles there are compared to how much solvent particles there are. And the most typical way we measure this is with, oh, there I go, I showed how you can take some away to make a lower concentration too. I forgot that I did that. Is this, the common way to show concentration is to use something called molarity. Moles of solute over liters of solution. And let's look at our concept map. And I'm actually going to put them into these different spots. Let's, since we have this digital, it's going to be very nice. Let's go to the back of the reference tables, if you can get a digital copy of the reference tables. And we have concentration right here, molarity. So I'm going to use that. I'm going to take a screenshot of that little spot and pop it over into there. Little small. Percent by mass we've done before. We'll look at that in a little bit. Let's go back to the presentation. Okay, so how do we use this equation? Let's take a look at it. Right, that bottom is not the solvent, it's the entire thing. It's the solute and the solvent together. So this question, how many moles of NaCl are needed to make a 1.5 liter solution at a concentrate of what we call 2 molar, which means moles per liter? How many grams of NaCl are needed? So let's do the first question. We can see that there's 2 of them right here. So first of all, how many moles of NaCl are needed to make a 1.5 liter solution? So let's look at our givens. Okay, our givens are this 1.5 is the liters. This 2 molar, this 2m is the molarity. So let's plug those values into the equation in the appropriate spot. So we're going to put 2m and then moles of solute, and then liters of solution is 1.5. So moles of solute, which is technically the moles of NaCl, is 3 moles. And we do that MOL like that, okay? How many grams of NaCl are needed? Well, we're going to do a mole calculations equation next. So that from the reference tables, let me get there. Let's look at our reference tables and see the mole calculations. This number of moles in a given mass, gram formula mass, we've used that before a ways back. So let's use it again. So we know the number of moles is 3. So I'm going to actually put that over there, right? And the given mass, we don't know that. That's what we're trying to find. Let me do a better question mark. Trying to find that. What's the gram formula mass of NaCl? Well, if you recall, we use the reference tables. We use the periodic table, and we add up the mass of the Na and the mass of the Cl. So we're going to take 23 for Na and 35.5 for the Cl. Okay, so the gram formula mass, let me go back to that for you. Okay, there we are. The gram formula mass is 23 grams per mole plus 35.5, which gives us 58.5 grams per mole. All right, that's what we're going to use for the gram formula mass. So we'll have 3 equals mass, which is our grams, and then 58.5, and we'll to solve for the mass, we get, where's my calculator? Get 58.5 times 3, we get 175.5 grams of NaCl are needed. And that's our example for that. We do have other types of concentration. We've done percent mass before. It's a very common thing we were doing. We weren't using it as a concentration. We were finding it the mass of a particular element in a compound. I'm going to do for you here, I'm going to share this presentation with you eventually, and you can see how this is done. I am going to put an example problem in this slide for you. I'm not going to work through it all, but this will help you with this. We should probably put the percent mass example into our percent mass composition right there. Let's put this into our concept map as well. It's so tiny. If another way to do it, you could do that a different way. And then we'll do percent volume next. So percent mass and percent volume are very similar to each other, right? You don't have to. Oh wait, that was going to be the example. Oh my gosh, I didn't do the example in the right spot. That's okay, we'll figure that out later. So percent volume is this, and then I'll put the example for percent volume here. Basically, the difference between percent volume and percent mass is that you just use mass in one and volume in the other, and you have to recognize volume units and mass units. They're basically the same equation, as any percent equation really is pretty much the same thing. Let's go put our percent volume. I don't know if there's a percent volume on the reference tables. I don't think there is. In fact, I'm not even sure I've ever seen a question on the Regents exam about percent volume. I have seen parts per million though, and that's the last type of concentration. So percent parts per million is this on the reference tables. It's right there. It's basically what percentage of oops, I don't want it there, I want it here. Since that 1% volume is now in the reference tables, I'm not going to super worry about it. I don't think they're ever going to be a question. We'll just put NA there. I've never seen one in 15 years of teaching this. I will be mad if they decide to do it now. Hee hee. I'll be like, you tricked me. So we'll put an example of parts per million. And then, lastly, we need to know how to make a solution of a known concentration. So let's take a look at that. And I'm going to have you do an exercise with that on Monday, how to do this. So what mass of sodium carbonate is required to prepare a 2-liter solution of 0.25 molar sodium carbonate solution? We're going to use that equation that we had before. The first one, the molar concentration equation. So let's take a look at the concentration, the very common one that we use in chemistry. All right, so let's use this one. And find out how much mass. This is actually basically the same thing that we did before with the sodium chloride, with just different numbers. So we're going to have this here, and we're going to have this here. So if we plug that in, the moles of sodium carbonate is 0.5 moles. But we need to know what the mass is, so we're going to have to figure out what the formula is for sodium carbonate. First of all, we know sodium is going to be plus, and carbonate is on table E. Let's go to table E, Mr. Josephs, okay. Carbonate is right here, CO3 2 minus. So CO3 2 minus, they come together to make Na2 plus CO3. Now we need to know the gram formula mass for that, and add them all up. I'm going to use this equation right here, the mole calculations equation again. The gram formula mass, what I'm going to do is cheat. And I'm going to Google it. Gram formula mass of sodium carbonate. It is 106 grams per mole. Perfect. Not really cheating, by the way. So this is 106, unless you're told to find it and calculate it. So that's that. The moles is right here. So when we multiply by 0.5, our given mass is going to be half of that, so it's going to be 53 grams of sodium carbonate. And how do we actually prepare this solution? Well, I'm going to show you. What we would do is, since we need to have 2 liters, no, not 2 liters. What is it? Yeah, it is 2 liters. Okay. We have to have a 2-liter solution. Okay, so it's going to be eventually this is the 2-liter mark right here. We're going to take our 53 grams of sodium carbonate. So let's just say we have a bunch of it right here. We're going to put it into the beaker. All right. So that's going to go. Let me get rid of this one thing. I'm going to put this stuff into the beaker. Yay! Woo! Okay. So that goes down there. Then what we're going to do is, I'm going to see if I can get better. We're going to put some water in there. All right. Woo! Very blue water. My goodness. But we're not going to fill it all the way up. Then we're going to stir that up a bit, okay? And it'll get stirred up, and when it does, hopefully all that stuff will dissolve. And trying to grab this. So it will dissolve, and it will be in the solution. Only then should we fill up the rest of the beaker to the 2-liter spot. Because if you were to fill it up to the 2-liter spot first and then put the solute in, what's going to happen? That water level would go up and you wouldn't have a 2-liter solution anymore. It would be greater than that. And we need to have it exactly at 2 liters. Okay? So the steps for making a known concentration are these. Let me find it. Hold on. These are your steps. Boom. Okay? Any questions on that? That is concentration in a nutshell.